Okay, I'm back. So a weird little snafu. Somebody knocked at the door and I panicked and I didn't know what to do. So I stopped and I answered the phone and I probably should, or I answered the door, and I probably should have just kept teaching. So hopefully you're back at the right spot. We're on our slide 110. Okay, so I have just found two places where we don't want X to be because it would give our a 0 in our denominator. So if I was talking about this from a domain point of view, I would have a cute little -4 right there and a cute little -3. Make sure you have them in the correct order. Open circles there. I don't want any of that. So my domain would be, am I still on the paper here? Yep. My domain would be -infinity to -4, union with -4 to -3, union with -3 to infinity. So there's our domain. In terms of our vertical asymptotes, please notice that it's x equals -3. Now, when I'm in class and I say, hey, what's the vertical asymptote? You're going to tell me -3, -4, and I'm going to say, nope, you're only partially right. Okay, you can't tell me -3 and -4. I know what you mean, but that's not correct. The correct answer is x equals -3 and x equals -4 because it's actually a line. A vertical asymptote is actually a line. So if I were to ask you to graph these two little cuties, it would be 1, 2, 3, 4, -4, -3, and we would have vertical asymptotes here and here. So that's what the graph would start to look like. There's more graph happening, obviously, that we would have to graph with it, but that's would be the beginning of our graph. Those vertical asymptotes would be. So there's 3 examples of how to deal with, how to find your vertical asymptotes. And so now you have a homework assignment that goes with 2.6. That was literally all of 2.6. So now we're going to hop ahead to 2.7, which is finding horizontal asymptotes. Horizontal asymptotes are determined by the degree of the numerator and the degree of the denominator. Okay, time out. Horizontal asymptotes are determined by the degree of the numerator and the degree of the denominator. Okay, so it says there are 3 rules. If the degree on the top is less than the degree on the bottom, then your horizontal asymptote is y equals 0. What on earth does that mean? So let's come down here where there's a little bit of space and put number 1. If the degree on the top is less than, that's what this symbol means. Maybe I need to write that there, less than the degree of the bottom. So if the degree on top is less than, so that would be something like this. Degree on top is less than, so let's say x over x squared minus 4. If the degree on the top, this is to the first, is less than the degree on the bottom, this is to the second, then our horizontal asymptote is y equals 0. Okay, there's an example of number 1. Number 2, here's an example. If the degree on the top is equal to the degree of the bottom, then it's the leading coefficients. So let me show you what that might look like. So let's say you've got 5x over 3x plus 1. Your horizontal asymptote, because the degree is 1 on top and the degree on the bottom is 1, your horizontal asymptote is the leading coefficients. So it's going to look like this. Notice it's not 5/3, it's y equals 5/3. Okay, and then the third situation is if the degree on the top is greater, that's what that means, greater than the degree on the bottom, then there is no horizontal asymptote. So if you have something like this, so if you had something like that where the degree on the top is bigger than the degree on the bottom, the horizontal asymptote is there is none. Okay, hopefully that makes okay sense. Now we're going to practice it a couple of times so you'll get to see it in action. Hopefully you're getting that right, written all down. I don't know if you can hear, but my phone is blowing up. Super popular. It's time you guys recognize. You better recognize. There it goes again. It's just over and over. Very popular. Okay, so here we go. Let's see. Find the domain and any horizontal asymptotes. So I'd rather that be the vertical asymptotes. We're going to change our directions. Find your vertical asymptotes and any horizontal asymptotes. So vertical asymptote would be x plus 1 equals 0. So our vertical asymptote is going to be x equals -1. Horizontal asymptotes. To figure out if there are horizontal asymptotes, we're going to look, what's the degree in the numerator? It's 0, because there is no x there, so it's going to be 0, whereas this is x to the first. So this one's smaller than this one or less than this one. So that takes us back up over here to the first one where it says if the degree on the top is less than the degree on the bottom, then y equals 0 is the horizontal asymptote. So going back, the degree on the top is less than the degree on the bottom. So there's like a cute little x to the 0 right there that we don't write. It's like a ninja one. So you can see that this degree is less than this degree to the first. So that means that y equals 0 is our asymptote, horizontal asymptote. So here's our vertical asymptote, here's our horizontal asymptote. Don't tell me it's 0, tell me it's y equals 0. All right, let's try it again. Let's change these directions to find the vertical asymptote and any horizontal asymptotes. So x minus 6, our denominator equals 0 is how we're going to find any vertical asymptotes, and that's going to be x equals 6. So we just found that one. Now let's talk about horizontal asymptotes. Horizontal asymptote, we're going to look if the degree on top is greater than the degree on the bottom. You see how that's a 2 and that's a 1, so this one's bigger. So up here it says if the degree on the top is greater than the degree on the bottom, then there is no horizontal asymptote. Bam, nailed it. Okay, let's have another shot at this here. Where are we? Okay, next slide. Find the domain in any horizontal asymptotes. So I'm not doing domain, we're doing vertical asymptotes there. So I'm going to do 7x squared plus 5 equals 0. So 7x squared equals negative 5x squared. Ew. Do I like this? Set it equal to 0, subtract that over, divide by 7. Take the square root, you get plus or minus this nonsense. So there is no way this will, well, that makes sense. There is no way this will ever equal 0 because this is always positive and then you're adding to it. So this is always going to be positive, which means there is no, how do I want to phrase that? No vertical asymptote. No vertical asymptote because the denominator will never equal 0, but you don't have to write that, but that's the truth of the matter. And then now I've got to find my horizontal asymptote. Sorry, I have to be consistent in my labeling or it bothers me. Horizontal asymptote is going to be numerator, denominator. Wait, what did it say over here? Let's see. If the degree on the top is equal to the degree on the bottom, then it's just your leading coefficients. So my leading coefficients are a 2 and a 7. So y is going to equal 2/7. So that is my horizontal asymptote. So that just gave us 3 practice. Ooh, can you see? Sorry. That just gave us 3 chances to practice finding vertical and horizontal asymptotes. Okay. Graph of rational functions. Let's see. So now we're actually going to graph them. We're going to use what we just learned about vertical asymptotes, what we just learned about horizontal asymptotes, and what we already know about finding zeros and such to put this whole dang thing together, and it's going to be amazing what we can do. So rules for graphing rational expressions. We're going to find and plot your y-intercept. We're going to plug in at x equals 0. I'm not plug in at. We are going to plug in x equals 0 and see what our y-intercept is. We are going to find our x-intercept. How do you find an x-intercept? You let y equal to 0. That's weird that they wrote it like that, that we wrote it like that. But, oh, I'm sorry. That's not y equal to 0. That's your numerator. Let's put that in parentheses here. Okay, and then find and graph your vertical. That's going to be set your denominator equal to 0. Numerator and denominator. And then we're going to find our horizontal asymptote using the 3 rules, and then we're going to plot the appropriate amount of extra points, and I'll talk to you about what an appropriate amount of extra points is, and then we're going to connect the dot with a smooth curve. Okay, so let's see here. All right, so I'm going to go boom, 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 boom. First thing I'm supposed to do, according to my little list over there, is I'm supposed to find and plot your y-intercept, and to do that, I let x equal 0. So I'm going to find what is f of x or y equal when I let x equal 0. So my intercept is going to be 0, 1/3. Yuck. All right, 0 1/3 is going to, oh, that's negative, Stephanie. So something like that. Not beautiful. Don't be afraid of it, though. So now I've got to find and plot my x-intercept, and to do that, I'm going to let the numerator equal 0. So basically, if this fraction right here is going to equal 0, it's because the numerator is equal to 0. If the denominator is equal to 0, it's undefined, and I've got a vertical asymptote. So in terms of finding when this whole thing right here is going to equal 0, I actually can ignore the denominator and only look at the numerator. I'll say that again. To find when this whole thing is going to equal 0, I need to know when the numerator is going to equal 0, and I actually don't care about the denominator, because if the denominator were going to equal 0, I'd have bigger issues, which is a vertical asymptote. So I kind of, in this situation for the x-intercept, I kind of ignored the denominator, and I really just look at the numerator and say, when is that going to equal 0? And the answer to that question is never. So there is no x-intercept here, because that 1 is never going to be a 0. So this little sucker does not cross the x-axis apparently, so we'll have to see what that looks like. That's weird. Okay, so we'll see what happens. All right, so next we're supposed to find the vertical asymptote, and to find a vertical asymptote, it says right here we set the denominator equal to 0, so we're going to do x plus 3 equals 0, and we find that the asymptote is x equals -3. So I'm going to come over here and go -1, 2, 3, and I'm going to draw in my vertical asymptote, which looks like that. Now, a graph will never cross a vertical asymptote. A graph can cross a horizontal asymptote, but it will never cross a vertical asymptote. So now I'm supposed to find the vertical asymptote using the 3 rules, and the 3 rules are: if your degree on top is bigger than the degree on the bottom, oh, no, I'm sorry, this one's the degree on top is less than the degree on the bottom. So that tells us our horizontal asymptote is 0. So that, now we know why there is no x-intercept, because we actually have a horizontal asymptote right here that's not going to be crossed. Uh-oh, hopefully you can see still, sorry. Okay, so I just plotted everything that I've got here is on my graph. Next it says plot the appropriate amount of extra points. So this is going to be an x and a y chart. And it's just like when we were doing the other ones. Do you see how I have one divider of my graph x-axis wise? So this one divider of my graph is telling me I need to pick a couple of values over here and a couple of values over here. So I'm going to say 2 to the left of this intercept and 2 to the right of it. So what is this at? -3. So I'm going to go -4, -5. And then on this side, I'm going to go -2, -1. And I like to, and we already know what 0 is. And so yeah, let's see what happens. So now this is a matter of substituting all this nonsense in, which I probably should have had done if I was smart. So this would be 1. Okay, don't tease me. I'm going to do mental math right now. This could go grossly wrong. 1 over -5 plus 3 is going to be what? -1/2, I hope. Okay. And then if I substitute in a -4, I get a -1. If I substitute in a -2, I get a 1. Is that right? Yep. If I substitute in a -1, I get a 1/2. Okay, so now at -5, I am at -1/2. That's right there. At -4, I'm at -1. And then if I were to do -3.5, it'd be somewhere right in here. Basically what's happening, the behavior of these guys is that they will get close to both of these asymptotes but not touch them. And so it kind of gets closer and hugs in both directions. Now I'm going to plot -2, and I jump up to +1, and I go to -1, and I go to +1/2. So now you can kind of see how this is going to be like this. Ooh, that was terribly done by me. It'll never actually cross right there, even though my graph's not that beautiful. It'll never cross right there. So there we have it, friends. We just graphed a rational expression. All right. And I'm going to bust through the next two because I don't have a ton of time. So I'm talking fast and going fast, and I apologize. Maybe Mr. or Mrs. Sub could pause this for you every once in a while so you can get caught up. Sorry about that. Okay, here we go. I'm going to do this kind of quickly if I can, and then we're going to skip down to a slide 120. Okay, so number 1, what are my steps? I need to find the y-intercept, and that means let x equal 0. So f of x equals 1 minus 0 over 1 minus 0. So this is a 1. So that means y equals 1. There is my y-intercept. Step 2 is find your x-intercept, and to find your x-intercept, the directions say let your numerator equal 0. I don't care about my denominator, because if my denominator equals 0, then I've got an asymptote. What I care about is the numerator equaling 0, so I'm going to do 1 minus 3x equals 0 and find out when that happens. So at 1/3, 0. And I'm going to go plot both of those things. So here I am at 0, 0. I want 0, positive 1. And I want 1/3. Uh-oh, did I just do that right? I can't really tell where my lines are. I guess that's, okay. Okay, so that's that. And then now here I am at 0, 0. And I'm going to go 1/3, 0. So it's going to be something like that. Step 3 is to... I don't know, do something. Oh, find your vertical asymptotes. So vertical asymptotes are going to be, 1 minus x equals 0. Set your denominator equal to 0. 1 equals x. So now I know over here at 1, it looks like that. Now I'm going to find some horizontal asymptotes. Am I horizontal? Please tell me this thing's still recording. Ooh, yay, it is. Okay, horizontal asymptote is going to be looking at the degrees. These degrees are the same, so it's the leading coefficients. Now, we put this one in here to trick you because we're tricky people. I want this right here. I want those coefficients. So it's actually y equals -3 over -1 or y equals 3. So now I'm going to come up here and go 1, 2, 3, and draw a horizontal asymptote right there. Now I'm supposed to do this sufficient number of points nonsense. So I've got one asymptote, so I'm going to do a couple points to the left, and I'm going to do a couple of points to the right. And so if this is 1, I've already got 0. How about we try -1? Oops, try to get Miss House. So -1. If I do -1, that's going to give me 1 plus 3 over 1 plus 1, which is 4/2, which is 2. So I've got -1. I've got -1. Is that right? No, that's 0. Sorry, that's 0. It's really hard to see on this. I apologize. That's going to be -1, 2, 1, 2, like this. I don't actually need to do another point over there. I can already tell it's going to go like this and get really steeply down. So what I need now is this is x equals 1. I need to be on that side of it, and so I'm going to go, let's try 2. What happens if I put a 2 in up here? 2, that's going to be -5 over -1, which is 5. So for 2, 1, 2, 3, 4, 5. And I'm guessing that if I plug in a 3, it's going to be somewhere in this area, so let's try that. So it's going to be 1 minus 9. And then this one's going to be 1 minus 3. So this is -8 over -2, which is 4. So here I am at positive 3. 1, 2, 3, 4. Hey, now it's going to look like this. If you need to do another point so that you can see that for yourself, you should. You could put in, try another one like 4. Try another one in the other direction like a -2 and see what's happening. If you know how to use your calculator well, it should only take you a second and it would let you see what's really going on. We're going to skip this one. You're going to get a chance to practice in class, and so you'll do one similar to that, and we're going to go down and do this one because it's a little bit more interesting, and this will be our last one because I got to go. Okay, so what am I doing? Okay, number 1. Are you ready? We've got to find the y-intercept. So to do that, we're going to let x equal 0. So we're going to have a 0 in the numerator. 0 plus 0 minus 2. So this whole it's a 0. So that tells us that our y-intercept is 0, 0. Step 2 says find the x-intercepts. And to do that, we let the numerator equal 0. Again, we don't care about the denominator in this situation. We care about the denominator in a minute when we're talking about vertical asymptotes, but right now when we're talking about this whole thing equaling 0, we really only care about the numerator. And hey, shocker, guess what? It's 0, 0. It's the same thing because obviously that works for both. So step 3 now is to find your vertical asymptotes. And to find vertical asymptotes, we're going to take our denominator. Now we care about the denominator, and we're going to set it equal to 0. We're going to factor like a mad dog, x and x, 2 and 1. I want this to be positive, and I want that to be negative, I think. So x equals 1, x equals negative 2. These are our two asymptotes. So I'm going to come over here. This thing sucks. Here's 1. So I'm going to go boop, 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 like that. Then I'm going to go to negative 2, 1, 2, doop, 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 doop. Now, those are my two vertical asymptotes. I've already got those on there. And I know that the graph goes through 0, 0. I forgot to plot that, but there's that information for my two intercepts. Step 4 is, what is my horizontal asymptote? Let me move that up. That's a weird dot for my 4, but we know I'm weird. Okay, so now I'm supposed to be looking at the degrees here. I'm supposed to look at the degree in the numerator is smaller than the degree in the denominator, which tells me y equals 0 is my asymptote. Wait a minute. Didn't we say that you can't cross over asymptotes? Yes, we did. We said you absolutely can never cross over a vertical asymptote, but on occasion you can cross over a horizontal, but you won't cross over it much. It'll go straight through and keep on trucking the other direction. So we don't know exactly what's happening, so we're going to try several points here. That's what makes this one a little bit trickier. So I'm expecting it, I'm going to draw over here for just a second. I'm expecting it to look something like this. It's either going to go, you know, like this, that part will stay pretty much like it's been, and then I might have kind of like an x cubed-ish looking thing, or I could have something more along these lines. Sometimes it goes like this. You still have, oops, I forgot my horizontal asymptote. You still have this part, you still have this part, and in the center part, you might end up having like a parabola or something that looks like that. Or some variation thereof. So we have to figure it out because we don't know. I think it's going to be this one because it actually obviously goes through, so it's probably not going to be this situation. It's more likely going to be that one. So let's kind of see what happens. So what are we doing? I don't know. Okay, what is this? This is at negative 2. So let's try negative 4, negative 3. Let's try negative 1z's. And then let's try 2 out here. So what is this at? Good Lord, what is that? 1, 2, 3. Okay, so now I've got to sit here and do math for a minute, and don't judge me because I have to do it in my head. That's going to be negative 8 over 16 minus 4 minus 2. So what is that? 6, that's 10. So this is negative 4/5, I think. So negative 3, let's have a do-over. This is going to be negative 6 on top. On the bottom is going to be 9 minus 3 minus 2. So that's a 4, negative 3/2, I believe. Please double check me on your calculator. Don't assume anything ever. So this is going to be 1. Do you guys miss me? Probably a lot, huh? I'm sure the sub's very nice, but I know you miss me. Dang, I hope I did that right because I was talking. Okay, let's try 2. So we're going to get 4 over 4 plus 2 minus 2. So is this a 1-er? I hope. And then 3 is going to be 6 over 9 plus 3 minus 2 equals, that's a 1, 10. So this is going to be 3/5, I think. Okay. Does that instill confidence when your teacher says maybe or I think? Negative 3 was at negative 3/2, so that's right here. Negative 4 was at negative 4/5, so that's actually more like right there. So I think what this dude's doing is going like this. Okay, then let's see. Now I need to do negative 1 and 1. Negative 1 is up at 1. Now, I think this one's going to do this because it's going to hug the asymptotes still. I think it's going to look like that. You could try 1 or 2 more points in there if you felt like you needed to. And then 2 is going to go up to 1. 3 is going to be at 3/5, which is like that. And this one goes kind of like this. Something along those lines. Beautiful graph. Okay, friends, so now you've got work to do. You've got 2 assignments. This is 2.6, this is 2.7, and then a worksheet that puts it all together and practices the graphing. So this is 2.6, I believe. This is 2.7, and then this is the worksheet to practice graphing. I think this is finding horizontal asymptotes. This one's, oh, maybe I lied. This one's finding horizontal and vertical. I don't know, I'm a liar. You'll get in there and see it. So I've got my book. You're welcome to use my book to take pictures. Assuming the sub's okay with that, you can use my book to take pictures of the work and then go sit back down and get to work and make sure you get the worksheet as well. And I will see you on Wednesday, and I expect you to have used your class time wisely and done these notes as well as the work. Peace out.